Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
I totally spaced out.
And you're Kim.
I'm still Kim.
And
Oh my gosh.
And y'all, you found a place where we're a little punch happy here, where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships and laughing when appropriate.
Oh my gosh.
We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps isn't fun and actually keeps students from being the mathematicians they can be. Hey, Kim.
Hi, guess what?
Gosh, yes.
We're going to talk fractions again today. I love fractions. Not as much as percents, but I really do like fractions.
You know, it's funny because when I first met you, I think you said something like, "Oh, I really prefer percents." But the more I worked with you, I was like, "You really love fractions." Like, I know you love percents more, but that doesn't mean you like fractions any less. Like, you like fractions. It's good. Fractions are good. Fractions are our friends.
I hear you have some strings for me today.
Yes, let's string. So everybody, pick up your pencil, pen, whatever your favorite
you said
writing.
Pencil first.
Well, I said whatever your favorite writing utensil is. Who was just telling me they were going to send me a box of mechanical pencils? Haven't gotten it.
You will hate those. Don't do it.
If I'm going
to,
I tell you what, if I'm going to do it, it will be mechanical. It will not be.
Do you actually own any Ticonderogas?
I do.
Okay.
I do. But none of them are sharp.
That's the problem.
I'll tell you what, when my kids were in school, we had this really, really nice pencil sharpener.
Mm-hmm.
And so we always had sharp Ticonderogas around. Mm-hmm. And that made it doable. And I don't know what happened to the pencil sharpener. I honestly
Sounds like you need a Christmas present.
Sounds like somebody should have gotten me one for Christmas. No, it's fine. I'll put it on next year's list. Okay, here we go. Ready? Kim.
Yep.
What is 1/2 of 36?
That'd be 18.
And how do you know? I know. Do you just know half of 36?
Yeah.
Okay. Could you, if a kid was
sure.
like
half of 30 and half of 6, so half of 30 is 15 and half of 6 is 3.
Cool. Good enough.
Or you could do over half of 40.
Oh.
And then back up half of 4.
Nice. Wait, half of 40. Mm-hmm. Yeah, I had to think for a second.
That'd be 20.
Okay. What is 1/4 of 36?
That would be 9 because half 1/4 is half of a half.
Huh?
And so half of the 18, which was half of 36, gives me 9.
So we could think about 1/4 of something as half of the half.
Yeah.
Of that thing. Cool. Mm-hmm. Is there another way that you might think about 1/4 of 36?
I mean, I could divide 36 by 4.
Mm-hmm.
And so 36 divided by 4 is 9.
Yeah, and if you know 4 times 9 and you're thinking about 36 divided by 4, that can be cool. Sure. So kind of 2 different ways to find 1/4. You can divide by 4, but you can also think of half a half.
Yep.
Cool. What is 3/4 of 36? 3 1/4 of 36.
Yeah. If 1/4 was 36 was 9, then 3 1/4 is 3 times 9, so that's 27.
Cool. I have confidence you have an over strategy for that one in you somewhere.
Yeah, I could. 4/4 of 36 is 36. So I want a fourth of 36 less than that. And you just asked me 1/4 of 36, which was 9. So 36 minus 9 is 27.
Bam. So you can think of 3/4 as 3 1/4,
Mm-hmm.
or you could also back up a fourth from 4/4.
Yep.
Nice. What is 1/3 of 36?
It's
Yes.
a dozen eggs.
Oh, okay.
It's 12.
Do you buy eggs in 36s? And
No, but sometimes we buy 3 12s. The
ah,
big ones don't fit in the fridge well, but we can stack 3 dozen.
okay.
Um, and so if my whole amount is all the 36 eggs, then a third of them would be 12 eggs.
Cool. And so you're thinking about 36 divided by 3 a little bit,
Yep.
kind of?
Yep. Yep.
And 3 times 12 is 36.
Mhm.
Cool. Um, you got anything else? I'm just curious. I don't know that I do.
A third of 30 and a third of 6.
Yeah, okay. A little partial
Mhm.
quotients there. All right. How about 2/3 of 36?
That's just 24. So if you could have 2 1/3s,
Okay.
so 2 12s,
Hmm.
or if you want me to go over, then I could say all of it would be 36. That's 3/3, and back the 1/3 that you just asked me. So 36 minus 12.
Is also 24. Cool.
Hmm.
How about 1/6 of 36?
Oh, that's 6.
How do you know?
Because 6 times 6 is 36.
Bam. Hmm.
Um,
Is there a relationship between any of the other ones we've done? I have them all written down. I don't know if you were writing them down.
I
Um,
did. I did write them
okay.
down.
Sweet.
So I could get from 1/3 to 1/6 uh, by dividing in half. So a sixth is a half of a third.
Hmm. Hmm.
And so 6 is half of 12.
Nice. Nice.
Um, we'll go
I'm,
see if there's any other.
yeah, dying
I
for.
could go back to a half of
Okay.
36.
Uh huh.
It's kind of like backwards of what I just said. 1/3 of a half is 1/6. So 18 divided by 3 is 6.
Cool. And how do you know a third of a half is a sixth?
Say it out loud, Kim. So if I have a half of something and I want a sixth of them, then I have to cut each one of those halves into thirds.
Nice. And I'm actually picturing fraction bars. If I had a
Hmm.
bar and I
Hmm.
wanted to cut it into halves, thirds, sixths, to cut it into sixths, I could do it two ways. I could fold it in half and then fold that into three. Once it's in half, fold that into thirds. And when I unfold it, like you just said, each of those halves would be in three pieces,
Hmm.
and so that would give me six. So that's a half split divided by three.
Hmm.
But I could also have folded the first original one into thirds, kind of that, as you sort of jury rig it until it's like
Hmm.
equal in their thirds, and then cut that in half. So half of a third is a sixth, or a third of a half is a sixth.
Hmm.
Nice. Cool. What if I wanted 5/6 of 36? I can't say sixths without spitting. Five
Yeah. I don't
sixths.
think anybody can. 6/6 is 36. So I'm going to go back a sixth, which is those 6 eggs in my mind still. So
Mm.
36 minus 6 is 30.
So 5/6 of 36 is 30. Cool.
Hmm.
Can
Hmm.
you also think about it as 5/1/6 of 30?
Oh, yeah, yeah. Let's scale up from 1. So that'd be 6 times 5.
Yeah. So
One
like,
sixth. Uh-huh.
sorry, go ahead.
1/6 is 6. 1/6 of 36 is 6. So I need 5/1/6. So I'm scaling it by 5. So 6
Because,
times
yeah,
5.
nice. Because 5/6 is 5/1/6.
Hmm. Hmm.
Okay. Almost done. What is 1/12 of 36? 1/12 of 36.
Um, I went back to 1/6 of 36.
Oh,
And I know it's going to be half as much as that. So that's going to make it 3.
So one.
half of a sixth is a 12th.
Nice. Nice. Got anything else for a 12th of 36? I like the half of a sixth. I like it a lot.
Yeah. If I go from a third to a 12th,
Uh-huh.
then I'm divided by 4. So I could, on the other side of my what I'm writing down, I could do 12 divided by 4, which
It's
is 3.
3. Okay,
Mm-hmm.
cool. Cool.
Mm-hmm.
Anything else?
Half to 12 is divided by 6.
18 divided by
18
6.
divided
Cool.
by
Cool.
6.
Yeah. How about from a fourth?
You could go from a fourth to a 12th divided by 3. So
Nice.
9 divided by 3 is 30.
And what if you didn't have any of those? And I just said 1/12 of 36. You didn't have
Then I
any
could
of
do
them.
36 divided by 12.
And that's also 3. Cool. Last question.
Uh-huh.
11 twelfths of 36. 11 twelfths of 36.
12 twelfths is 36. So 11 twelfths is 3 less than that. So 33.
Nice. Nice over
Mm-hmm.
to think about 11 twelfths. You could also have thought about 11 1/12ths, right?
Yeah, and that's not bad because it's 11. So 3
Mm.
times 11. But sometimes scaling up that much can be funky.
Yeah, and we would probably do the scaling times the unit fraction first.
Yeah.
But today we thought we would kind of do a little bit of both,
Yeah.
scaling the unit fraction, but also backing up just that one unit fraction from the whole to get things like 3/4, 2/3, 5/6, and 11 twelfths.
Yep.
All of those were one unit fraction away from the whole. So purposeful ordering of problems in a string. Yeah, nice. All right, cool.
So I knew we were going to talk about operator today.
And you're saying that. Let me actually just say that for just a second. Sorry for interrupting. So that idea of thinking about 1/4 of something, 3/4 of something, 1/12 of something is kind of treating fractions as operators. And that is one way, it's one of the 5 interpretations of rational numbers that we need to help students deal with and have experience with. And so we could do a problem string like we just did to help students really think about this operator meaning of fractions. And then Kim, go ahead. You wanted to talk about how you did something just the other day with it.
Not too long ago, I did a string similar to this in a 4th grade class. And just to see, like what could happen. And so the string was half of 16, no problem. And then we did 1/4 of 16, also fine. And then they asked them 3/4 of 16. And what I realized as they were kind of fumbling around about it is that it wasn't the operator meaning of fractions that they were having some difficulty with. And it wasn't necessarily thinking about multiplication. The struggles were absolutely knowing that 3/4 was 3/1/4. And I know they had done some work with fractions, and there was probably some assumption on my part because I hadn't been in the classroom before. But we definitely needed unit fractions, like we had talked about in some of the other podcasts we've done. That in order to do some of this work, kids have to really make sense of 3/4, not as 3 out of 4, but as a scaled up from 1/4. So I think it just occurred to me in that moment that there was a lot of I don't know if it was missed opportunity or just not knowing what the kids knew or didn't know at that time. But we are saying here on the podcast 3/4 and 3/1/4. But it was incredibly challenging to attempt to do this particular string because they did not see 3/4 as 3/1/4. And so then the next thing I did was 1/8, not so much of a problem, but they didn't see that was 16 divided by 8. 16 divided by 8. So they were kind of like cutting things apart and seeing what they could find. But then again, when we got to 3/8, it felt like a whole brand new problem.
They weren't able to once they had fussed around with 1/8 of 16 and they found that was 2, they couldn't then use that to think about 3 of those 1/8s.
Yeah. And so some of the precursor work of knowing non-unit fractions from unit fractions was something that I made a suggestion with the teacher that they could continue to work on, because some of this operator meaning stuff that we're doing has everything to do with scaling up from the unit fraction.
Mhm.
Um, anyway, so I just, I knew that we were going to do this operator meaning of fractions, and, I wanted to just share some of the challenges that I had had
Mhm.
and some of the work that, I feel like can be done in order to make this string that you and I did more successful.
Yeah. So if students have only ever had a part whole, if they've only worked with fractions as a part whole representation, and so they're
Hmm.
looking at a problem like 3/8 of 16, they're like 3, 1, 2, 3 out of 8, 1, 2, 3, 4, 5, 6, 7, 8 of 16. Ah! Like
Yeah.
it, that we need the multiplicative relationship. Thinking about 3 1/8, like you kept saying, like scaling that unit fraction 3 1/8, the unit fraction of 1/8, if I know that's 2, 1/8 of 16 is 2, then I can scale that multiplicatively. And that's another example of how fractions really are multiplicative in their nature.
Yeah.
And then they're not only multiplicative, 3 1/8, that's multiplicative, but then 3/8 of 16 is really proportional. And we're
Yeah.
really dealing with 3/8 is a proportional relationship of 16, and we can get at it as sort of breaking it into that multiplicative thing. Yeah, nice. That doesn't mean that the work that you did that day was all for naught, right? Like that,
No.
it was
Oh my gosh,
brilliant
we had
work.
the best conversations. Absolutely. And I think that's what happens, right? You go in sometimes with a goal in mind, especially if you're walking, if you're an interventionist or a
A
coach
guest
or a leader,
teacher.
or yeah,
Hmm.
in any of those kinds of situations, you're walking in, sometimes having a conversation with the teacher ahead of time and having different understandings of what it might look like to say my kids know unit fractions, or but then sometimes you just make assumptions about a class, and you get to take it into a different place. So that's why it's super important that the terrain, and all the important bits of mathematics around the thing that you're doing, because I was able to then say, okay, we're not going to do this kind of over thing. We're going to now simply work on what is 2/3 as it relates to 1/3, what is 4/5 as it relates to 1/5.
Nice, nice.
Yeah.
Yeah, and it reminds me of your mantra, know your content, know your kids.
Mm.
In that instance where you're a guest teacher and you cannot know the kids, at least at the, your goal is to get to know them as much as you can in the conversation,
Yeah.
then it's so important to know the terrain so that you can
Yeah.
shuck and jive with them as you get
Yeah.
to know them. Yeah,
Definitely makes it more
absolutely.
challenging.
Yeah, cool. All right, Kim, let's end with a different problem string that has a
Okay.
different sort of slant on this idea of an operator meaning of fractions. What does it mean to treat
Okay.
fractions kind of as operators? It's a little bit of a different slant. So,
Okay.
first problem. If I said 1/5 of a number, some random number, one
Okay.
fifth of that number is 8. One
Okay.
fifth of the number is 8. If that's true, what's 2/5 of that number? Maybe pause just a second so people can think. If 1/5 of a number is 8, what's 2/5 of that same number?
That would be 16.
How do you know?
Because I'm just doubling the amount that you first asked about. So I'm going from 1/5 to 2/5 to 1/5. So 8 times 2 is 16.
So you just didn't even figure out the number. You just were like, "Well,
Oh,
I
was I
know if."
supposed to figure out the number?
No, no, no.
Okay.
I'm just acknowledging. I'm acknowledging that
Okay.
you're like, well, if 1/5 of whatever it is 8, and you're just asking me for two of those,
Yeah.
well, then it's just two of 8 is 16. Is that
Yeah.
kind of how you were thinking?
Yes.
Cool. What if I said a fifth of a number? Could be a different number. Could be the same number. What if a fifth of a number is 8? What's 4/5 of that number?
Well, it's gonna be the same number. Uh, and so, but I'm still gonna scale. So from 1/5 to 4/5 is it's gonna be times 4.
Hmm.
So 8 times 4 is 32.
Cool. I'm a little curious. The first problem we said 2/5 was 16. Could you scale from
Oh
there?
yeah, yeah. Okay. Yep.
So you could double the 16 to get 4/5, two
Yep.
fifths to 4/5. Cool. If 1/5 of a number is 8, what's 1/10 of the number?
It's gonna be 4, because a tenth is 1/2 of 1/5. We know a fifth is 8.
We know a fifth is 8, and a
Yeah.
tenth is a half of a fifth, and half of that 8 is 4. So you're saying a tenth of the number is 4?
Um, yes.
Yes. Okay.
Sorry.
It's all right.
I had to think about what you were
I
asking.
just kind of said it backwards. Okay. So Next question. If a fifth of the number is 8, same scenario, what's 9/10 of the number?
9/10. Okay.
Mm-hmm.
So you just asked me 1/10, and that
Uh-huh.
was 4.
Mm-hmm.
So 9/10 is going to be 36.
Because.
Um, because I could scale out times 9.
Mm-hmm.
But also I'm thinking about if 1/10 is 4, then 10/10 would be 40. I think it's the first time that I thought about because I wanted to go over here. So it was the first time I considered what the whole amount was so that then I
Ah.
could back up from it.
And so if the whole is 40,
Yeah.
1/10 of that's 4,
Mm-hmm.
9/10 is 4
30.
back from 40.
Uh-huh.
And that's another way of getting the 36.
Yep.
Let's back up, actually, if you don't mind. Now
Sure.
that you think the whole is 40,
Yep.
I had asked you if 1/5 of the number is 8, what's 2/5 of the number? Does that, knowing that the whole is 40, like finding 2/5 of 40, does that make you,
No, I don't love that. I was still
yeah,
going to scale up.
still want to just scale from the 1/5 to the
Yeah.
2/5? How about the 4/5? When I said 4/5
No, I
of
like
the
I like scaling better.
just scaling. Cool. I wonder if the 4/5 for me might have been, if I know 5/5 is 40,
Yeah.
and we started with 1/5 was 8, then I could back up the 8 from the 40 to get the
Yeah.
32
I
for the
just don't think
4/5.
I think for whatever reason I didn't necessarily think of going 5/5 and back a fifth to get to 4/5.
Yeah, but you
I
did
don't know
when it was
why. Yeah.
the 9/10 kind of, yeah.
Yeah, I don't know why.
And so is it bad or
Horrible. I'm bad. And horrible.
or are we just being flexible? We're just like,
Yeah.
what are we thinking about? And
Yeah.
kind of go from that. All right. So the last question of the string is, if 1/5 of a number is 8, what's the number?
So, yeah, 40.
And you already had found out that it was
Yeah.
40. Cool. So that's different problem string that kind
Yeah,
of
I don't
gets.
know that we've done one of those.
Yeah. I have a bunch of those in lessons activities for building powerful
Oh,
numeracy.
good to know.
Yeah, it's a different way of kind of working on both operator meaning and the scaling idea, that if you've got 1/5, then how can you find 2/5? And if you've got
Yeah.
1/5, how can you find 1/10? What's the relationship between a fifth and a tenth?
Yeah.
Yeah, very nice. Cool.
Very nice. All right. So, I wasn't going to share a review, but I think we have a little bit of time. So
Oh, okay.
this is super short.
Mhm.
And it says, great for experienced educators who love teaching math. That's the title. I like when the title is like also something fun.
That's cool. That's a great title. Yeah.
I can't even read the jumble of the letters, so I'm
You
sorry.
mean the person's handle
Yes,
is
sorry,
crazy?
sorry. But this says awesome content presented in ways that inspire and clarify. I like the
Oh,
clarifying, right? So I sure hope we've done
nice.
that today. Hope everybody enjoyed listening in as we talk more about fractions.
Hey, and let me just maybe say thank you so much for the review, person with lots of letters and stuff in your name. It says great for experienced educators who love teaching math. I mean, I think it's good for
Anybody.
inexperienced educators too.
And non-educators. We've had lots
Oh
of
yeah,
moms and
parents
dads
and all
and
the things.
for anybody. Math's for everybody.
But we sure appreciate the 5 stars and the review. That helps other people find the podcast because we are trying to spread that word. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.